Okay, so here we're on section 6.2. All right, so what is this section about? Well, it's about graphing exponentials. That's what this section's all about. Graphs of exponentials. So graphs of exponentials. So in other words, so 6.1 was about exponential functions, and now 6.2, the graphs of those exponential functions. So in general, then what's an exponential function? Well, it's something of the form a times b to the x. Remember, exponential means x is in the power zone. That's what exponential, it's an exponent. X is in the exponent zone. So in other words, it's not just something like x squared. That's got an exponent, that's got a power, but x is not in the power, x is in the base. That's not exponential. Whoop, can't spell it here. That's not exponential. I'm going to erase that anyway. Just want to make sure you know. All right, so x is in the power zone. That's exponential. So what we want to think about is what's going to happen. So let's take this first one. Let's take y equals 3 times 0.7 to the x. And what I want you to think about in this section, what will make this easiest, is think about first off, if you're going to make a table and you made x 0, what would the y value be? You'd get y equals 3 times 0.7 to the 0, right? If x is 0, you plug in 0 right there for x. Now, what you want to be clear on is what is any number to the 0 power? Like what is, let's just pick any number. What is 4 to the 0 power? It's 1. Do you remember that? Do you understand that? Let me prove to you it's true. Maybe that would be helpful to show you. What if let's start with something like, I don't know, 3. How about we had 3 to the 4th power? That means 3 times 3 times 3 times 3, which is, equal to 81, because it's 9 times 9, right? 3 times 3 is 9, times 9, 81. What's 3 to the 3rd power? Well, it's 3 3's multiplied together, you know that, which is 27, right? 3 times 3 is 9, times 3 is 27. What's 3 to the 2nd power? Well, it's just 2 3's multiplied together, which is 9. What's 3 to the 1st power? It's just 1 3. So look at these answers, because the next ones come in 3 to the 0. But I want to answer it not by a rule. Math isn't so much about rules as it is about logical patterns. So look at the pattern here. How does 81 become 27? How does 27 become 9? How does 9 become 3? What's happening there every time? How does 9 become 3? You divide by 3. How does 27 become 9? You divide by 3. Divide by 3. See how we're dividing by 3 every time? 27 divided by 3 is 9. 9 divided by 3 is 3. So then follow the yellow brick road. Follow the pattern. Do the same thing. So what is 3 divided by 3? 1. You see, it's got to be 1. To see the pattern there? Anything to the 0 power is 1. That's just true to the pattern. Okay, so what? Well, then that means this is 3 times, what is 0.7 to the 0? What is anything to the 0 power? 1. So this is 3 times 1. This is 3. So that number in the front, that's where it is when x is 0. Because if you plug in x 0, this part just becomes 1, and y is just that number in the front. So over 0 up 3, that's right here. That's the dot over 0 up 3 on the graph. Okay, now let's think about what happens as we plug in like 1 or 2 or bigger numbers. So we get 3 times 0.7 to the 1. If you do that in your calculator, you'll get 2.1. And then if you do 2, you'll get 0.7 squared. And so what is that going to be? It's going to be 3 times 0.7 times 0.7. What happens every time you multiply by 0.7? That's less than 1, right? That's a number less than 1. It's a fraction. So if you're making it lower, aren't you? When you multiply by a number less than 1, see how when I multiplied 3 times 0.7, it came out 2.1, it went lower? So when we do this again, Here, I'm doing my calculator. I'm getting 1.47. See how it's making the answer lower? Every time it was 3, now it's 2.1, now it's 1.47. If we did it again, 3 times 0.7 to the third power, just use your calculator. I'm getting a 1.029. It's going lower and lower and lower. If I did 4, let's do one more. 0.7 to the fourth. I'm getting 0.7203. It's under 1 now. It's going lower and lower and lower because if you're doing more and more, a higher power of 0.7, 0.7 is less than 1. You're multiplying by something less than 1, which makes it smaller. When you multiply by a number less than 1, a fraction. That's what a decimal or a fraction less than 1. If you multiply by something less than 1, then your number gets smaller and smaller and smaller. So the further we go to the right on this graph, it's going down, 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 isn't it? You see that? It's got to be. So it's going down. So it's one of these graphs that's going down to the right, right? It's either K or R. We don't know which one yet. It's either K or R. It's going down to the right. See, the numbers are getting smaller and smaller and smaller. Now let's try. So this is, that's that one. Let's try the other one here. 3 times 0.8 to the x. Let me get rid of this stuff here. And let's think about what happens with that one. So we're going to make an xy table again. You know when x is 0, when you plug in 0 there, you're going to get 3 times 0.8 to 0. Anything to the 0 is 1, so that's just 3. Good. And then the next one will go 1, 2, 3. So you go 0.8 to the 1. Calculator will tell you it's 2.4. Then 3, 0.8 to the 2. To my calculator, I'm getting 1.92. And then 3, 0.8 to the third. I'm getting 1.536. So it's going down, again, because we're multiplying by 0.8, which is a decimal, something lower than 1. So you're multiplying lower than 1. It's going down. Now, so in other words, this one also is going down to the right. Numbers are going down, down, down. But which one's going down faster? This one's 3, 2.4. This one's 3, 2.1. This one's going down faster, isn't it? Why is it going down faster? Well, because 0.7 is a smaller number than 0.8. 0.7, you're multiplying by 0.7, that makes you go smaller faster. It's going down faster. This one is going down faster. So this one's K, isn't it? This one's K. It's going down faster. This one's R. It's going down, but not as fast. Now that we've got the idea, let's take a look here. Look at this one has a 4 in the front. What does that mean? Remember that number in the front? That A? The number in the front, is where it starts on the y-axis. In fact, it's the y-intercept point, isn't it? That's what that A is. It's supposed to be an arrow there. It wasn't a very good arrow. So that A is where it starts on the y-axis. So that which one starts up at 4? This one starts at 4. This one 3. Right? So that's B. This is the B. Okay, now these both start at 3. They're both going up to the right. Now, why are they going up? Because they're multiplying by a number bigger than 1. See how that's a number bigger than 1, whereas 0.7 and 0.8 were a decimal smaller than 1. But 1.24 and 1.43 are both bigger than 1, so they're going to go up to the right as you plug in bigger and bigger numbers. Why don't we do one of them just to be 100% sure? It's good to see it. So let's just take the, let's just do that first one. How about if we come over here and we go, okay, I'm going to do xy, I'm going to do the y equals 3, 1.24 to the x. So plug in 0, we get 3, 1.24 to the 0. remember, anything to the 0 power is 1. That's just going to be 3. 3 times 1, 3. Plug in 1, and we're going to get 3, 1.24 to the 1. Sorry, I'm getting a little scribbly there. 1.24 to the 1. I'm using my calculator. It's going to get bigger than 3 because we're multiplying by a number bigger than 1. We're multiplying 3 by a number bigger than 1. So I got to 3.72. Let's plug in 2. So it's 3, 1.24 to the second power. It's going to get bigger again because you're multiplying by another number bigger than 1. I'm getting 4.618, I'll just say 4.6, etc. It's getting bigger. See, it's getting bigger as we go to the right because you're multiplying by a number bigger than 1. So both of these are going to go up to the right. Which one's going up faster? Well, the 1.43 is a bigger number. So that one's going up faster. So which one's going up faster? So we're talking about these two that are going through the 3. They both start at 3 on the y-axis. So it's either this orange or the green. The green one's going up faster, right? This one's going to be the green that's going up faster, and the orange one is going up from 3, but not as fast. So there we go. That's how we do that. Let's look at number 2. Similar kind of thing. We're looking at different graphs here, and they're giving us the equation y equals ab to the x, and they're saying, okay, which of these graphs has the largest value for b? Now, what's b? It's that part. So remember what a and b are. So a is the y-intercept. It's where the graph starts at x equals 0, right? Because if you plug in x equals 0, a times b to the 0, anything to the 0 power is 1. A times 1, write that a little better there. A times 1 is just a. So it's where the graph starts. Okay. So maybe we should jump down and do this one first. Which graph has the largest value for a? Which one starts at the highest point? This one here, huh? This is going to be the green one, isn't it? That one starts at a higher point than the other 3 graphs. Okay? Let's go back up here now. Which one has the largest value for b? Largest value for b. Now, what is b's role? Well, b, if it's more than 1.0, it goes up to the right. If it's less than 1.0, then it goes down to the right. Remember on the last problem? That number that comes, that has the x power on it, that's the number because you're going to plug in x1, 0, 1, 2, 3, 4, 5, bigger and bigger numbers. So if that's a number under 1, you're going to multiply by a number under 1 again and again and again, which makes your answer smaller and smaller. If you multiply by a number bigger than 1 again and again, it makes your answer bigger. So the b tells you whether you go up to the right or down to the right, if it's more than 1 or less than 1. So which one's going up to the right? Largest value of b is the one that's going up to the right the fastest. That would be this red one, wouldn't it? It's going to be red. And which one's smallest value for b is going to be the one that's going down to the right the fastest. That's going to be this orange one down here, isn't it? It's going down to the right the fastest. So it's got the smallest value for b, much less than 1. There we go. Okay, so number 3. Now, similar kind of stuff. And so let's start with the graph. Let's think about the graph of y equals 2 to the x. If you let's just make a little table for that real quick. So if you make an xy table, if you plug in 0, you get y is 2 to the 0. Anything to the 0 power is 1, right? Plug in 1. 2 to the 1 is just 2. Plug in 2. 2 to the 2 is 4. Plug in 3. 2 to the 3 is 8. You can just see it's going up, up, up as we go to the right. So a quick little graph of this would be, let me see, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. So at over 0 up 1, over 1 up 2, over 2 up 4, over 3 up 8. So it's rocketing up like that. And exponential graphs always rocket up or down on one side and flatten out on the other. So it must be flattening out on the other. So that's what 2 to the x looks like. Now, what's going to happen if we put in negatives and things like that? Okay, well, two things we got to look at here. What does it mean if we take and we put a negative in front, like that one does? Oh, first off, do you see, I should answer, which ones clearly looks like this green one right here? So that's 2 to the x, that's the green one right there. Okay, now what's it going to do to put a negative in the front? Well, it's just going to make all those same answers negative, isn't it? Just going to get -1, -2, -4, and -8. So the graph will be over 0, down 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3. So over 0, down 1, over 1, down 2, over 2, down 4, and over 4, down 8. So it just goes like this. Remember, it flattens out on the other side. So there's what that graph looks like, just like that. Somehow, I'm not sure what happened to my picture here, but let me go over here and get a fresh screen. Okay, so here we go again. So we already answered this one is the green one. So y equals 2 to the x. We made the little xy table, plugged in 0, 1, 2, and 3. Got 1, 2, 4, and 8. And the graph basically looks like that. And now we're trying to graph, so that was the first graph. Now we're trying to graph negative in front. Like, what's that going to do? We make an XY chart for that. 0, 1, 2, 3. It's going to be the same answers, just negative. So -1, -2, -4, -8. All these same answers, just negative. And so when you do the graph, 1, 2, 3, 4, 5, 6, 7, 8, it's going to be 1, 2, 3, over 0, down 1, over 1, down 2, over 2, down 4, and over 4, down 8. So it's going to go like that. They always flatten out. Remember, exponential graphs always rocket up or down on one side, flatten on the other. They always do that. So it must flatten on the other. So it looks like that. So which one looks like that? That's the red one, isn't it? That's the red one there. Okay. So now the real question is, what's going to happen when we put these negatives up there? What is that going to do? It's kind of it's a good and new question. So, in order to answer that, let me erase this stuff for a second. And let's try to answer that. So, a negative up there in the power zone, let's do like y equals 2 to the minus x and see what happens. First off, you have to realize that means 2 to the -1 to the x. You can kind of separate it, right? Because a negative x really means -1 times x, doesn't it? Negative x is -1 times x. And so I can separate it. And then, do you know what is 2 to the -1 power? Do you know that that's a half? So let me make sure you know that first off. Let's go back. Let me show you. Let's start with like 2 to the third. 2 to the second. I want you to show you it's not just a math rule, it's the truth. 2 to the third is 8, right? Because that means 2 times 2 times 2. 2 times 2 is 4 times 2 is 8. 2 squared, 2 times 2, 4. 2 to the first is just 2. And what's happening in the pattern? Let's just follow the pattern now. We're not going to do some rule. We're just math is logic and patterns. What's happening? How does 8 become 4? 4 become 2. What's happening? Divide by 2 every time. Divide by 2. So the next one, divide by 2. So 2 divided by 2 is 1, and we know that anything to the 0 power is 1. Now, What's the next one? What comes next in the pattern? 2 to the 3, 2 to the 2, 2 to the 1, 2 to the 0, 2 to the negative 1, right? That's a pattern. 3, 2, 1, 0, negative 1. I'm just following the pattern. I'm not doing anything other than following the yellow brick road here. Now, rather than writing some answer, what has this got to be? Well, I'm just going to follow the pattern. What are we doing every time? Divide by 2, divide by 2, divide by 2. Do it again, right? Math just is patterns and logic. Divide by 2. So take 1 divided by 2. It's a half. Aha. So there's the proof of it. 2 to the negative 1 power is a half. So what did that negative do? It flipped it down to the bottom. That's what negative powers do, so you need to know that. So any number to, like, 2 to the negative 1 is a half, 2 to the 0 is 1. So you really want to know those two rules well for exponents, for powers. Anything to the 0 power is 1, and a negative power flips to the denominator. We proved it right here. It's just simply the truth. It's the pattern. Just follow the yellow brick road there. Okay, so what then? Okay, so great. So that's what I'm saying here when I say that, erasing all that, when I say that 2 to the minus 1 is a half. So this is really a half to the x, right? 2 to the minus x is really a half. When you see that negative up there in the power zone, you have to realize that flips it. So 2 to the minus x is 2 to the minus 1 to the x, which is really a half to the x, because a negative power flips things to the denominator. Okay, great. So what? It's a half. Well, remember what that means? This is less than 1. This one's a fraction less than 1. Earlier we had decimals less than 1. Same deal. It goes down to the right, doesn't it? Let's go back over here. Remember back here when we, back in this first question, we were dealing with 0.7 and 0.8. They were less than 1. So that means it went down to the right. Then when we dealt with numbers bigger than 1, they went up to the right. Remember that? Same thing for fractions, no different. So less than 1 down to the right. So therefore, when you see a negative power, let's do this one first off. 2 coming on down here. 2 to the minus x is going to go down to, which one goes down to the right? Well, this yellow one. This yellow one goes down to the right. Now, okay, now how about this one? Let me just do this last one now. How about this one? This one is going the negative power, so it's going to go down to the right. That's true. But then what about the negative? What does that mean? Well, yeah. Rather than say down to the right, I'm going to say it flattens to the right, because that's really what it does, right? The numbers flatten out. And then the negative in the front, what does that mean? It's a negative graph. It's down below, so it's this blue one, isn't it? So that's a negative graph. It's going down, but it flattens. It flattens on the right. So it flattens on the right, and it goes down the other way. It's the blue one. Even though I'm writing it with a red pen, it's a blue one. And whereas this yellow one goes up and then flattens on the right, because it also has a negative power, so it also flattens on the right. Flattens on the right, but it goes up the other side. So there we go. So basically, here's a nice summary. If you have a negative in the front, so if you have a negative here, the graph, it goes negative, and this negative here means that it flattens to the right. It flattens to the right. So it flattens to the right, and this negative means it goes negative. So that's why it goes like that. It goes negative, and it flattens to the right. Okay, so we're learning a lot about exponential graphs and how they work. A negative in the front means it goes negative, and negative on the x is really a half because it flips it, and anything less than 1 goes down, or I should say flattens. That's a better way to, more clear. It flattens to the right. All right, let's go on to number 4. So here's number 4. Now, again, they want us to match the graphs up on number 4. So let's do that. So, okay, so first off, 1/4 to the x. This is less than 1, which means the graph is going to flatten. It flattens to the right. But over here it's positive, isn't it? It's not negative like that next one. It's positive. So it's a graph that's going up. It's a positive graph. It's a positive graph, but it's going to flatten to the right. Which one? So we're looking for a positive graph that flattens to the right. It's looking like this one, isn't it? Positive graph which flattens to the right. Positive graph which flattens to the right. Yeah, so this one is A. This one is equation A. Let's do the next one. What about this one? This is a negative graph. Right, it's got a negative in the front, but it also flattens to the right because it's got a fraction. It's got a number less than 1 with the power x on it. So as x gets bigger and bigger and you like 10th power, a fraction multiplied 10 times is going to get super small. It's going to flatten to the right, but it's a negative graph which is flattening to the right. It's this one. This one's going to be B, isn't it? Because that one's flattening to the right, but it is a negative graph. Good, okay. So now let's try this next one. This one is a negative graph, and it goes up to, well, I'm not doing that very clearly. It launches to the right. It's a negative graph and it launches. Yeah, I should be saying, instead of up or down, what I should say is it launches on one side, flattens on the other. That's what all exponential graphs do. Let me just show you the idea. It flattens, all the graphs flatten on one side, launch on the other, but they can do it different ways. This one is going to launch to the right because it's got a number, it's a negative graph because of that negative, and then 2 is bigger than 1, right? 2 is bigger than 1, so when your base, the thing that has the x power on it, is bigger than 1, it's going to launch to the right instead of flatten to the right. So it's a negative graph which is going to launch to the right. See how it's now it's going to launch down. Why? Because it's a negative graph, and it's going to flatten on the other side. So it launches to the right, and it's a negative graph. Which one does that? That one right there. There's graph C, formula C. And finally, the last one, this one right here, 2 to the x. That one is positive. So it's going to go like this, isn't it? It's going to launch to the right because it's 2 is bigger than 1, and it's a positive graph. So it's this one right here, 2 to the x. So this is formula D. There we go. So that's what it's all about. So if you have a fraction less than 1, then that means it flattens to the right. If you have a number bigger than 1, like 2, 3, 4, whatever, that means it launches to the right. but we don't know if it launches up or down. How do you know that? Well, that's the sign in the front. Positive in the front, it's launching up. Negative in the front, it's launching down. It's always going to launch one side or the other. It's just a matter of whether it goes up or down. All right, let's try number 5 here. Starting with the graph, f of x equals 6 to the x, write the equation. Okay, now we're going to shift graphs around. What about if you shift it 7 units upward? What's going to make that graph go up? Remember, up, down is out front like that. And then when they say left, right, left, that's going to be up here with the x. So is it going to be x minus 5? Instead of out front, it's up with the x. But it's actually the other way. It's like that. Do you remember that from moving graphs around? This means up 7 because it's a y effector. It's not in x's world. Remember, there's 2 places you can be. You can be up here in x's world, and then you're in x effect, and that's actually going to be left 5 because x is opposite. Remember, whenever you're next to x, you're opposite. So positive 5 is left 5, actually. The positive 5 means left 5. And negative 5 would mean right 5. And this one's a y. It's a plus 7. It's a y. It's up 7 because it's not in x's world. It's not up there with x. It's not an x. It's a y. It's an up-down. And then finally, reflected about the x and y axis. Well, what's going to cause reflection? If you have, here's the normal graph like this. This is like 6 to the x. Y equals 6 to the x. If you do y equals negative, let me write it up here. Negative 6 to x. That negative makes it go down, doesn't it? Now it launches down, it's a negative graph. And if you put the negative up there on the x, remember what that does? That means it flattens to the right. Flattens to the right. And it's a positive graph that flattens. So it's a positive graph that flattens to the right. Remember that? So do you see what's happened there? Comparing these guys, comparing 6 to the x and 6 to the minus x, it's been flipped about the y-axis. It's been flipped. It's like we grabbed the y-axis right here and we rotated it like a barbecue rotisserie. We rotated it, and that we grabbed this one and we rotated it, and that made this graph. See how there are rotation that way? It's been rotated. Let me just leave it over here. It's been rotated. You took the original one, the original normal 6 to the x that doesn't have any negatives anywhere, that goes up to the right like that, and we rotated, did a rotisserie about the y-axis. And it turned the graph sideways. That's what that negative does. It actually, on that x, it flips it sideways. Right, and that makes sense sideways because it's on the x. Anything in x's world is going to have a sideways effect on the graph. It does a sideways flip, a flip about the y-axis. And then this, notice this did a flip about the what? What is this? This is the x-axis. It flipped it down, right? It made it a negative graph. Right, because stuff out there is not in x's world. It's not on x. It flips the graph down. It's a rotisserie about the x-axis. So anyway, long story short, they've reflected this about the x and the y. So they did the rotisserie on both axes. What's that going to be? Negative in the front and negative on x. Both on that. All right. Let's try number 6. Do we have room? Yeah, we can do number 6 down here. Let's try number 6 down here. All right, let me get these guys out of the way. Okay, so what's up with number 6? Describe the long-run behavior of this graph. So as n goes to negative infinity, what's going to happen? So if we take minus 5 times 2, and you plug in like negative infinity for n. Y equals f. F is the same as y, right? What's that going to equal? Well, remember what we learned a negative power does. Let me write this a little better. It flips it down like that, and then the power becomes positive. All right, do you see that? Let me rewrite it down here, look a little better. Negative 5 over 2 to the positive infinity. So that's what you got to remember, like we talked about before. Negative powers flip to denominator, then the power becomes positive. So a good analogy is like somebody that's unhappy at their job. It's a negative person. They're negative. They're unhappy at their job, so they're unhappy where they're at, so they flip to the bottom of the fraction, and then they're happy. They flip to a new job. They flip to the other side of the fraction. They're not happy in the top, so they flip to the bottom, and then they become happy. The negative 5 is staying put, right? These guys were over 1, so to speak, before. But this part was unhappy. He flips to the bottom, and then he becomes positive happy. That's what negative powers always do. You need to know that when you're dealing with exponentials. Negative powers are negative. They're unhappy where they're at. They flip to the bottom, okay? And then what becomes of that? Well, this is minus 5 over. Now, what's 2 to the infinity? That means 2 times 2 times 2 times, like 100 times. That's just infinity. It's just gigantic, right? Now, what's minus 5 over infinity? Like, instead of infinity's hard, like, it's not a number. But what if we did, like, a million? That'll be like infinity for us. What is minus 5 over a million? Well, if you took, if you think about what's 5 million. If I said last night I ate, let's just do 1 million. If I said last night I ate 1/millionth of the pie, that's almost nothing, right? That's basically no pie. That's just dust, pie dust. That's virtually no pie. And you think, well, yeah, but this is 5 millionth. Whatever. It's 5 little pieces of dust. It's still basically nothing, right? 5 over. I ate 5 millionths of the pie, right? That's a millionth 5 times. That's 5 little dust pieces. That's basically nothing. So, yeah, but it's negative. Okay, so it's negative nothing. It's still nothing. The point is, it's nothing. So this is basically, this part is 0. So 0 minus 3, minus 3. So y, as n goes to negative infinity, y, or f, is headed to negative 3, isn't it? Headed to negative 3. Because that front part becomes 0. Because a negative power flips it to the denominator, and then 2 to the infinity is infinity. Let's say like a million, and anything over infinity is 0. 0 minus 3 is minus 3. What about as n goes to infinity? What about the second part here? N's going to positive infinity now. Well, that'll be y equals minus 5 times 2 to the infinity, plug in infinity for n, minus 3. So y equals minus 5. Now, what's 2 to the infinity? That'd be like 2 to the million again. Well, 2 to the million power means 2 times 2 times 2 times 2 times 2, a million times. That's just infinity. And minus 5 times infinity, millions and millions, is negative infinity. The answer to the second part is negative infinity. Minus 3, but that's still negative infinity. So the answer to that part, negative infinity. There we go. Number 7. The graph below shows a transformation of 2. So it's not 2 to the x, it's a transformation. Because here's 2 to the x. this is what y equals 2 to the x looks like, right? So this one's showing a transformation of 2 to the x. So what exactly did they do? How did they transform 2 to the x? They're saying it's something of the form a times 2 to the x plus k. We gotta find the a and we gotta find the k to answer this question. That's the two parts we don't know. It's like 2 to the x, but it's been changed. How do we figure that out? Well, I would basically just plug in this point. It's all about plugging in points. I'm going to make an xy table. Oops. Over here. Make an xy table. Make x 0. This is the point, what? Over 0, down 1. X is 0, y is negative 1. So that means y equals, what's the y formula? Well, it's this. It's a times 2 to the x plus k. And they want me to, I'm going to plug in 0 for x, and y is negative 1. So y equals a times 2 to the 0 plus k, and it equals negative 1. Does that make sense? So I plugged in, okay, let me do it over here. I plugged in negative 1 for y and 0 for x, right? So there's my little equation. So, what does that mean? Oh, actually, you know what? I'm forgetting something I should help you with. Notice this has a horizontal asymptote right here. See how remember, exponential graphs, they always flatten on one side and launch up or down. That says lanch. Launch on the other. So exponential graphs they always flatten on one side and launch up or down on the other side. And where they flatten, 2, this one's flattening at a height of 2, you can tell, that's the k. So let me write that out for you. Y equals, I should have written that from the beginning. That would have been helpful. Y equals a times 2 to the x plus k. That's always the flatten, the horizontal asymptote, right? Remember how we've been talking about asymptotes in this section? Sorry, I need to write that a little bit better than that. This is where the graph flattens. It's the horizontal asymptote. So it flattens at 2. So this equation, then I know this is a 2 back here, because that's the line where it flattens. So I know this is a 2. So now I can solve this little equation here for a. This is minus 1 equals a. What's 2 to the 0? 1. Right? Anything to the 0 power is always 1. So a times 1 is a. Right? A times 1 is just a. How do we finish solving for a there? Subtract 2. Minus 1 minus 2 is minus 3. So I've got a is minus 3. So this equation, y equals a times 2 to the x plus k. Now I know the a is minus 3. And the k is always the flatten. That's where it flattens, and that's at 2 plus 2. There's the equation. That's what they want. You can see they wrote it this way. That's the same thing. They just put the 2 in the front. That's exactly the same formula. The homework system will take it either way. All right, number 8. This would be the same thing, even a little more tricky. Same kind of thing. They want me to write the equation. Y equals a times, oh, and I don't even know what the base is, b to the x plus k. So we know less information this time. So, than we had on that last one, right? Okay, so let's see, what are we going to do here? Well, do we know can we figure out the k where the graph flattens? Where does it flatten? The height at which it flattens the horizontal asymptote. What's the horizontal asymptote? Right there at 1. So that part's got to be 1, doesn't it? So this is y equals a times b to the x plus 1. Okay, now let's plug in a couple points. We know this point right here, over 0, down 1. So that means you plug in x 0, y will be negative 1. So y is negative 1 when x is 0. So now we can solve that. What do we got? What is anything to the 0 power? 1. And a times 1 is just a. So then subtract 1 from both sides. Boom. A is minus 2. So we've got the a. So now our formula, we're getting closer, has become y equals a, which is negative 2, b to the x plus 1. We're to here. We just got to find that b now. We've got to find that b. So to find that b, so this was step 1 over here. Let me try to make some notes of this. So this was right here. Step 1, we found the k equals 1 by the horizontal asymptote. This is step 2, right here, where we found the a by plugging in this point, the y-intercept, right? We use the y-intercept. And now step 3, so step 2 was plug in 0, minus 1. Step 3 is going to be plug in one more clear point. What's another point that's right on a clear mark where two lines meet? Right there, huh? That's back 1, down 5, isn't it? Back 1, down 5, back 1, down 5 for x and y. So take the equation as we have it so far, y equals minus 2 times b to the x plus 1. And plug in x is minus 1, y is minus 5. And so what do we get? Minus 5 is minus 2 times b to the minus 1 plus 1. Okay, so now we can solve for b. So now you got to remember, what does a negative power do? Negative power flips to the denominator, then power becomes positive. Negative power, remember that? They're unhappy. A negative power means they're on, like somebody that's unhappy at their job, they're unhappy on the side of the fraction they're on, they're going to flip to the other side of the fraction. So it'll become negative 2 over b to the plus 1 plus 1. Makes sense? That's what happens there. Negative powers flip to the bottom and then become positive. All right, let's go on with solving this in. We got to subtract 1 from both sides. Gonzo. So we get minus 6 is minus 2 over b to the 1. B to the 1 is just b. I'm just going to write b. Now, how are we going to solve that? Well, how do you solve when you have a fraction? You put this over 1, cross multiply, don't you? So we get, let me come over here, minus 6 times b is, well, maybe that's not the best place. I'm over here. So minus 6 times b, right, these two multiply, and then these two multiply, is 1 times minus 2. So that's minus 6b is minus 2. How do you finish solving for b? Divide by minus 6. And then reduce that fraction. It's positive 1/3, right? The two negatives cancel to be positive, and they divided top and bottom by 2. b is 1/3. So that was a lot of work. So we have y equals a b to the x plus k. Now we know the a is negative 2. So this is negative 2. And we know the b is 1/3 to the x plus the k. And the k up here is 1 There it is, which is the answer they have there as well. So that one was more advanced, a little more tricky there. All right, number 9. So on number 9, they want us to give some functions. Again, writing exponential functions. Notice some of them are growing, some of them are decaying or flattening to the right. Okay, so how do you generally an exponential function is a times b to the x. You don't have to have the parentheses, they're optional. So, and then remember how we've learned that when it comes to a rate, because this one's all talking about the growth rate. The growth rate. So the b is the 1 plus r. Remember we had that in the last section? When you introduce a growth rate, where r is the rate. It's either the growth or decay rate. So there are two different ways of saying the same thing. You can say y equals a times b to the x, and that b can be replaced with 1 plus r, where r is the rate, the growth rate. How did I know to do that here? Well, because they're giving me the rate. They're all of a sudden talking about the rate. They didn't talk about that on number 8 or number 7 or number 6. All of a sudden they're talking about the rate now. So whenever they give you an exponential function and they talk about the rate, you've got to rewrite the b as 1 plus r. It brings the rate into the game. Okay, so an initial value, a is always the initial value. Remember, a is always where the graph starts on the y-axis. It's the y-intercept. So if initial value 976, this is going to be 976 in the front, and then the growth rate is 28%. So that's 1 plus 0.28. Make it a decimal, right? 28% is 0.28 to the x, like that. Now they want you to rewrite that 976. Make it 1.28. Because 1 plus 0.28 is just 1.28 to the x. There we go. There's that first one. Second one, growth rate's 9%. So this is getting, and the initial value is 1059. So 1059, 1 plus, now how do you do 9% as a decimal? 0.09. Remember, it always goes back 2 places, because that's why there's 2 zeros in the percent symbol. It's telling you move that decimal back 2 places. 1 plus 0.09 to the x. So that's 1059, 1.09 to the x. All right, next one. 2004 is the initial value. So 2004, 1 plus 7.5. Move back 2 places. 1, 2. It's going to be 0.075. Always 2 places when you go percent to decimal. That's why there's 2 zeros in the percent symbol. To the x, so that's just 2004, 1.075 to the x. Next one, growth rate's 113%. Started at 4903, so 4903, 1 plus. Now, how do you do 113%? Change it to a decimal. Where's the decimal right now? It's at the end of the number, right? Whenever they have a number and you don't see the decimal, you know it's really at the end of the number. So move it back 2 places, bonk, bonk. It's going to be 1.13 as a decimal. Again, percentages, changing to decimal, you always move it back 2 places. So 1.13 to the x. So add those up, 4903. 1 plus 1 is 2.13 to the x. 2.13 to the x, like that. Good. Okay, now they come in with a decay rate. Decay. So that flattens to the right. That's what we mean by decaying. It starts at 1238. 1238, 1 minus. So for decay, it's minus. That's the only difference. You put plus or you put minus. This can be plus or minus in the middle here. It's minus, plus for growth, minus for decay. Something's decaying, something's going away, something's shrinking. So it's going down. 1 minus 0.14 to the x. So that's 1238. 1 minus 0.14 is 0.86 to the x, like that. That makes sense? So it's positive for growth, negative for decay. Decay means going down, flattening to the right. Let's try a 6% decay rate starting at 1445. So 1445, 1 minus 0.06, right? The decimal goes back 2 places. So that's 1445. What's that? 0.94 to the x. Last one here. Oops. Last one. We're going to say this one's got a decay, so it's negative again. Decay rate 0.6%. So 239. So we start at 239. Now 0.6%, back 2 places, is going to be 0.006 as a decimal. So 1 minus for decay, 006 to the x. So that's 239. Subtract that on your calculator to get 0.994 to the x. There we go. So whenever they bring in the rate, we rewrite our b as 1 plus or minus r to the x, plus being for growth, minus being for decay based on the rate. And a is always the initial value. Number 10. Starting with the graph 6 to the x, write the equation. 9 down. Remember how we do that? So whenever we have 6 to the x, to make it go down, we'd go minus 9. How do you make it go left? You go x plus 6, up there in the power zone with the x, right? Because whenever something is, so let me say right or left is in x's world in the power zone. So whenever we're dealing with a right-left question, right-left is going to be in x's world because x does right-left, so it's in the power zone, and x does the opposite. So right is actually negative, left is actually positive. X does the opposite. Whereas up here, for this first one, up down is not in the power zone. It's not in x's world. It's not in the power zone. It's not in x's worlds. It's in the front. And positive is up, negative is down. Positive is up, negative is down. It's just normal. Y does normal. Y is normal, meaning positive up, negative down. X is opposite. So those are the rules there. Let's come on down and try this third one here. Reflecting. So remember what reflecting means. So again, it's so the normal graph of 6 to the x is like that. And if you grab the y-axis and you rotate it, then the graph will turn sideways, won't it? What does a sideways flip? Negative on the x, because that's a sideways flip. And then if you grab the graph and then you also grab this axis, which is the x-axis. Well, here, let's start with this one. If we rotate the x-axis here, then that flips it down. So it'll go down like that. If you can see that, I'm not sure I'm drawing that very well. So now it'll go down like that. What does that? Negative in the front, because that's a y flip. It's a down flip. Negatives in the front, not in x's world or an up-down thing. And then putting both of them together, if you do both, flip it sideways and down, then it'll go like this. This is negative 6 to the minus 6, both negatives. It's been flipped sideways and down. And that's what we have here. That's our answer. Because this one was reflected about the x-axis and the y-axis, both axes. So it's flipped down and left, and negatives are in both places on that one. Okay. Let's try number 11 here. Okay, so on this problem, what they're going to ask us for each of these questions, they're asking us, is it exponential or is it linear? And is it increasing or is it decreasing? Is it exponential or linear? Is it increasing or decreasing? So exponentials, so when it has x up in the power zone, that's exponential. And how do you know if it's increasing or decreasing? So it's, if this number is less than 1, the base that has the x on it, then remember that means it flattens to the right. That's what that, when you multiply by a number less than 1, it makes you smaller and smaller and smaller. It flattens you out. So that one is decreasing to the right. It's here, I'll just say DEC, decreasing. How about the next one? This one is exponential because y is in the power zone again. That's exponential. And is it increasing or decreasing? This number is more than 1, so it's increasing. Okay, now let's try the next one. This one is linear because it's just like mx plus b, right? This is just mx, this is y equals mx plus b. X is not in the power zone, exponent zone. It's just mx plus b. That's linear. Is it increasing or decreasing? Notice the slope, the m, is negative. So that's decreasing. A negative slope, that line is going down to the right. Right? Whereas this last one was an increasing exponential function, and the first one was a decreasing exponential function, decreasing to the right. Okay, part C, or the fourth one part D, this is linear again because it doesn't have the letter in the power zone. And this is the mx plus b. The m, the slope, is 33. That's increasing. That'd be a line that's increasing. The negative 80 just means it's going through a y-intercept of negative 80, but its slope is positive. It's increasing, going up. Okay, last one. This one is, t is up in the power zone, so that's exponential. And this is, the base is more than 1, so it's an increasing function. So it'd be an exponential function that's increasing to the right instead of flattening to the right. Right? When the base, so for exponential functions, whether they increase or decrease to the right, it's all about whether the base is more than 1 or less than 1. If the base is less than 1, if it's a fraction or decimal less than 1, like 0.9, then it's going to flatten, decrease to the right. It's going to go down to the right. Whereas if it's a number more than 1, then it's going to increase. It's going to go up to the right. It's going to launch to the right. And then for the linear functions, these two linear ones here in the middle, it's all about the slope. If the slope is negative, it's going down. If the slope is positive, it's going up to the right. All right, number 12. So we're taking 7 to the x. Remember how this works again? So the normal graph, y equals 7 to the x, is like that. If you grab it at the, let's say at the y axis and you flip it, then it goes like this. And where does the negative go? That's negative in the front because I'm sorry, that's not it at all. That's negative on the x because that's a sideways flip, right? That flipped it sideways. Everything that has a sideways effect, it does it in x's world. You got to put the negative in x's world. Whereas if you, oh wait, I'm forgetting. I'm already doing part C. So I'm starting with part C, basically. Let's keep going on part C. Whereas if you grab the graph and you flip it here about the x-axis, that's going to flip it down like that. That's y equals negative in the front because the graph flipped down. It flipped over the x-axis, didn't it? Whereas this one over here flipped across the y-axis. I'm not writing that very neatly. Flipped across the y-axis. All right. So that's for part C. Then what is gonna, or that's part B. I'm sorry, I'm doing part B, aren't I? Let's get this straight here. What am I doing? Reflecting about the y-axis. That's this one. That's a reflection across the y-axis. A sideways, it's y equals 7 to the minus x. 7 to the minus x. It's a flip across the y-axis. Sideways flip across the y-axis. And then coming up here, 5 units to the left. What makes something go 5 to the left? Remember how that works? So whenever we go left, put it down here again. Whenever we go left or right, that's x's world. X's world, which is the power zone. So, and it's opposite. X is always opposite. So negative, left is positive, right is negative. It's opposite. So 5 to the left, that's going to be, the basic function is 7 to the x. So 7 to the x, what? Left will be plus 5. Up in x's world, having a right-left effect, opposite, plus 5 is left 5. And then last one, coming down here. What about up, down? So up, down again. That's a y effect. Up, down is y, not x's world. It's a y effect. Up and down is not a sideways. It's a up and down. It's not x's world. It's not the power zone. Up is positive. Down is negative. Y is normal. You know, like what you'd normally expect. Positive up, negative down. So 2 down. So it's 7 to the x is our basic function. So 7 to the x. And then down to minus 2. Minus 2 right in the front out there. Or the back. I should call it the back. But it's not in x's world. There we go.